Hi, please don't watch this video until you finish the assignment from Friday, because Friday I want you to get the arithmetic sequence in your mind, and then this video is all about the geometric sequence. So make sure you finish Friday's work first. All right, so these are closely related, but a geometric sequence is one in which the ratio of any term to the term that directly precedes it is the same. And that ratio is called the common ratio. So we're talking about a ratio this time. So let's say we have the sequence 1, 4, 16, 64, and so on, like that. Well, you can tell that it's not arithmetic because they're not adding the same thing each time. They're adding different numbers. So it's not arithmetic. So geometric says if you take two terms, the ratio that you get from any term to the one that precedes it, the one that comes before it, is the same. So I chose 64 and 16. I could choose 16 and 4. 16 over the number before it is 4. So we have a common ratio. And you can do the division thing like that, or you can look to see what do we multiply by each time. So each of these is multiplied by 4. So we could get the next one by multiplying by 4. So that's how geometric sequence works. It's multiplying to get the next term. Let's do example 6. Write the first 5 terms of the geometric sequence. So we're doing the same types of examples. Whose first term is 4. And whose common ratio is 5. Okay, so we have some numbers here. I'm going to go through and assign them variables. If we want to write the first 5 terms, that's how many terms we're doing. That's n. It's a geometric sequence, so that's really important. If the first term is 4, that's a sub 1. And if the common ratio is 5, that's our R. Okay, so write the first 5 terms. I'm going to do my 5 blanks. And we know the first one is 4. If my common ratio is 5, I'm going to multiply. And that's how we get those first 5 terms. So it works super similar to the arithmetic, except we're multiplying. Then, just like with the arithmetic, we have a general or nth term formula that we use in this section for a geometric sequence. And I will give you these formulas, but you've got to know how to use them. A sub n, the nth term, is found by doing a sub 1 times r to the n minus 1. So let's use it with example 7. Determine the 12th term of the geometric sequence whose first term is -4 and whose common ratio is 2. So just like we've been practicing, let's go through and figure out what these numbers are. If we want to determine the 12th term, that's n would be 12. So that's our n. Oops, sorry about that. And it's a geometric sequence. If the first term is -4, that's our a sub 1. And if the common ratio is 2, that's our r. So to find a general term or a specific nth term, we use the nth term formula for geometric sequences. N is 12, so this is a sub 12. So the 12th term is a sub 1 is -4 times r, the common ratio is 2, to the n is 12 minus 1 power. You're going to pick up your calculator and, well, first, simplify 12 minus 1. Do the exponents first, so figure out what 2 to the 11th is on your calculator. It's 2048. Then multiply by that -4. So we would not have wanted to draw 12 blanks and do all that multiplying. It's easier to use this formula, possibly. All right, next, example 8. We're going to write an expression for the general for nth term a sub n of the sequence two, 6, 18, 54. So if they want the expression for the general or the nth term, we're going to write our nth term formula down. And as we try to work through it, we don't know what n is. It's our variable. It stays at n. A sub 1 is the first term, and that's this right here. That's our first term in our sequence. R we've got to figure out. So we can take any two we want and do one of them divided by the one in front of it. Or you can look to see what are they multiplying by each time. So your R is 3 to the n minus 1. And you can't actually do any more simplifying. That's as far as we can go, because we can't raise it to the power because it's still got a variable with it, and we can't multiply until we've done exponents. So lastly, we've got the formula for the sum of the first n terms of a geometric sequence. Just like we had the formula for the sum of the first n terms of the arithmetic sequence. It's when I was talking to you about little Carl. So the formula is S sub n equals A sub 1 parenthesis 1 minus r to the n over 1 minus r. And off to the side they just say r can't be 1 because that would give us division right here. So they're just keeping us safe. So here's our formula. For example 9, we're going to try to use this formula. It's your last example. Determine the sum of the first 5 terms of the geometric sequence whose first term is 4 and whose common ratio is 2. So they said it's a geometric sequence and they want us to determine the sum, so that's the S sub n formula. Let's just write it down. And I will put this on the board for you. I think we know everything we need. We are doing first 5 terms, that's our n. The first term is 4, that's our a sub 1. Common ratio is 2, that's our r. So S sub 5, the sum of the first 5 terms, is the first term times 1 minus our common ratio. N is 5 over 1 minus r. Whoops, and r is 2. So we have to do order of operations. So in the parentheses, we're going to do exponents. 2 times 2 times 2 times 2 times 2. And in the denominator, we can subtract. In the parentheses, we're going to subtract. We're going to multiply the numerator. And now we'll divide, and a negative divided by a negative is a positive. All right. There's a great example, 10. I might try to do it with you in class. It's as a reward for saving his kingdom from a band of thieves. A king offered a knight one of 2 options. The knight's first option was to be paid 100,000 pounds of silver all at once. The second option was to be paid over the course of a month. On the first day, he would get 1 pound of silver. On the second day, he would receive 2 pounds. On the third, he would receive 4 pounds. And so on, each day receiving double the amount given the previous day. Assuming the month has 30 days, which option would give the knight more silver? I guess we'll just do it right now. So this first option, it's doubling every day. So the next day is going to be 8, the next day is going to be 16. This is a geometric sequence because we're multiplying by 2 each time. So we want to figure out how much money this knight is going to have at the end of 30 days. So we'll do the sum of a geometric sequence. So there's 30 days in a month, they said. The first day he gets 1 pound. Common ratio is 2 to 30 days. Two to the 30th. I'm looking in the book. It's 1 trillion 73 billion. Oh, maybe that's 73. No, 1,073,741,824 over, in the denominator we'll get a -1. I'm going to drop this 1 that's getting multiplied by the parentheses because it's not going to change it any. So inside the parentheses, 1 minus that 1 billion is -1,073,741,823 over the -1. And a negative divided by a negative is the positive of that. So option A was that he would just be given 100,000 pounds of silver just all at once. In option B, if we doubled the amount we gave him each day for a month, he would get that. So there's a lot of benefit in being patient, because that is a whole lot more money than that first option. Okay. All right, that's it. I'll see you all Wednesday.